you so much for joining me today to the natural language processing tutorial on movie descriptions. And the plan for today is that we will take a look at movie descriptions of two different genres and figure out what are some of the most common words used in the descriptions, and also find out if the length of the movie description has anything to do with the duration of the movie. So in order to start, we have to import the libraries that we will be working with. One of them is the Matplotlib library, which we will be using for two data visuals, which we will be creating. Then we have a library called itertools, which I haven't used before, and today's the first time I'll be using it to connect a list of lists, and you will see shortly what that means and why we have to do that. Then we also need pandas and the natural language toolkit, which is a library for natural language processing, and it has some really great functions, built-in functions that you can use, such as word tokenize and a wordnet lemmatizer. And you can also use the counter method. So that is to count how often is a word occurring within the document or within a description. Lastly, we will import the stop words list, which is a list of words that are commonly used in a description or in a review that are not really giving much insight into what the text is about. It solely helps us to put the words together and to connect them. So after we import all these libraries, we have to also import the data set. And I will be using the IMDB movies.csv file, which is you can download on GitHub. On my GitHub, I will post it there. And it's also downloadable on the IMDB homepage. Okay, so now let's load the first 5 rows of this data set. And as you can see, there's a lot of different columns. We won't be working with all of them. So what I did is I reduced the data frame to a smaller set. And I want to only keep the title, the genre, duration, and the average vote. And after you have this data frame, it already looks much easier to understand. Okay, so one important thing when it comes to natural language processing is that you cannot have null values in the descriptions column. So we want to drop all the null values in this data set. So we will just use the df.dropNA method, and we will also pass it in place equal to true. We are not going to create a new data frame. We will simply copy it onto that data frame that we already created. And lastly, let's check if there's any more null values here. Looks like not. So we can move on to the pre-processing of textual data. Okay. So the first thing we need to do is create a variable. I call it stop, which basically saves all the words, all the stop words in English into this variable. And you will see that this is a list. After I run this cell, I'm going to show you what this variable contains. We also have to initialize the wordnet lemmatizer function, which will help us later to reduce the words in the descriptions column. For example, these here. It helps us to reduce it to its roots, and I will show you a difference later, what it is. Okay, so let me run this, and let me show you now what the stop contains. So you see that the stop is actually a list of words, and all these words are often appearing in textual data, but it doesn't really tell us much about the data. So we have to get rid of it. And in order to do that, we will first have to convert all of the description words that are here to lowercase. And I'm going to show you why. As you can see here, all these words in the stop list are lowercase. So if you have an uppercase word or a word that's not exactly matching, because, for example, the B in because is big or capital, it will not remove them. So that's why let's create a function to start the processing of the words, of the textual data. So we have to create a column that we call it lowercase. It will save all of the descriptions in lowercase. And what we do is we call the function, we call the column description and pass it on the string.lower method to reduce or to make them in lowercase. The second thing we can do now, because all of these descriptions are in lowercase, we can actually remove the stop words from the descriptions. So I'm gonna create a new column that says no stop words. So we call it no stop words. And now we are applying a function, a lambda function, to this column that we created up here. And the function is a list comprehension that will iterate through each word, over each word. And then if the word is not in stop words in this list here, it will save them, it will join the words and return them. And we'll save them here in this new column. So it's a little bit complicated to explain, but the most important thing is that you get familiar with list comprehension. It's very common in natural language processing if you work with data frames, because you want to make sure you can apply a function to each row in the data frame. Okay, after we remove the stop words, we will actually quickly change this. We will create another column, which is called tokenized. Tokenized means we will separate each word into its own, or separate it by a comma, basically, and create a list of it. df.apply is, again, we will apply a function called lambda. And this time we use this nltk.word tokenize on each row in this no stop words column. So in order to get the tokenized words, you have to apply this lambda function. Next step is to create, or to basically check each token that we have here. And let me first apply this function. Okay. So I'm gonna do something easier for you to understand. I'm going to I applied this function just so you can see what each of these things does. Okay, so again, this here, the first column we created is lowercase. Now each word is lowercase, as you can see here. So then we have removed all the stop words. And just to show you here, in is, for example, a stop word. So we actually removed that stop word from this column here and created a new column. then we tokenize the words when we use this nltk.wordTokenize function. And now we have a list of words in this tokenized column here. So let me just make sure. 1 second. Okay. So now the tokenized column here has no more stop words and is actually a list of lists. Next, we will check these tokens here. So all of these words that are separate now, if they're actually alphabetical. So if they are words or if there's numbers. So here the first example. Here you can see that 1950 is not an alpha. So it's not is not an alphabet. So it's actually a numeric value. So it was removed from these words here. And lastly, and sorry, again, to just make it a little more understandable for you, we create a new column. Here we apply a lambda function, which is again a list comprehension. So we look at each word. If the word is alpha, and if it is alpha, we will keep it in the data frame. And if not, it will be just thrown out. Lastly is to lemmatize each word here. Lemmatize means we will cut our word to its root form. So if you, for example, have a word makes, in this process called lemmatization, it will be reduced to make. And that is important because when you count the words, there's not really a difference between makes and make. So yeah, that's why you do lemmatization. Okay. So what I already did is I applied a function, which is called create tokens, onto our data frame, and I will save it in df_clean. So that way, when I keep working with it, I have a new data frame here. And next thing we need to do is, if we want to split a string into words and then count basically the length of words, create a new function, which I will call word count. And this function here will take a string object, and then it will basically split the string into its separate words. And we want it to return the length of the words. So we'll save each word into this variable here. And then we count how many words are in this word. So let's try it out. So after we run this function, we can test it. So this function here takes a string. So strings are like sentences, and you can pass it. You have to make sure you put it in this under parentheses. And now if we apply this, it returns 4. This means that this string here has 4 separate words. And here does not count the question mark as its own word. It simply counts the actual words. Okay, next thing we need to do is we want to create another function, which I call average word length. And in this function, we want to basically count the average word length. So first, to do that, we need to basically split each word into its own characters. So as opposed to this function here, it takes actually words and then returns the length of each word. And we also use a list comprehension, which will iterate over each word in the words variable that we have here. Next, it will calculate the sum of the word lengths and then divide it by the length of words to get the average. So now this function here, when you apply it, we can try it on one word. I'll try it on the word hello. It will return 5 because I only have one word. And the average will be 5 over 1. And that's how you get 5. Okay, now we want to apply these two functions that we just created to the whole data frame. And we want to apply it to the descriptions column. So I create a new column called num words, which basically saves the number of words that we get from this function. And we simply say, we want to apply this function to the df clean data frame and the descriptions column. And then it will basically go through each row and apply this function that we created up here and counts the word in the descriptions. We also will do the same approach to the description column. Just now we want to calculate the average word length. And because the average is always a division, mostly you will get some kind of decimals. So I will round it to 0 decimals. I want whole numbers. And lastly, what I can do is calculate the number of stop words. And how you can do that is you simply subtract the length of the descriptions that has no stop words from the descriptions including the stop words. And that basically gives you the number of stop words within that descriptions column. So after you apply these functions, I'm going to show you how your data frame now looks like. You will see that here you have number of words, average word length, and number of stop words of each description in your data frame. Okay, and once we have all these, we can proceed to the next step, which is the questions we want to answer with our data set. So first of all, we want to look at words that are most common in the descriptions of dramas that have a higher rating than 7.0. So in order to do that, first we have to reduce our data frame to make sure it meets the conditions. We want to only keep the column or the rows that are drama and that have an average vote greater than 7. So you can use this simple statement to reduce your data frame. And when you run it, you will see that all of these rows here are now just drama and have an average vote of greater than 7. Okay. Next thing we want to do is we want to check how often does each word appear within this data frame. The first thing we need to do is we need to create a list of the column lemmatized. So I'm going to save it under A. So we will simply use the statement toList to create a list of this data frame column. And before Okay, as you can see here, we have now only this, it's like a series object. You have only the lists with all the words that we just filtered before. And the problem is that we need actually, when we do this to list, it will basically give us now a list of lists. And this is problematic when we want to count all of the words that appear within drama, because technically it would simply go through each list here separately and count how often is a word coming up. But you will see that doesn't make sense because we are only having one word of each, and we want to check how often does unemployed appear within the whole document. So that's why we need to combine these separate lists to one. And the way we do that is first we have to create a list, and then we need to connect the list of lists with the iter_tool statement. So when I run this, this basically, this here means we count all the occurrences of the words in each list, and then we have to create a dictionary of the most common words, the most common 10 words, and save it into a new variable. So here you can see that life appears 45 times within this document. Story appears 24 times. Father appears 23 times, and so on. So this basically gives us already some great insights into what words are most commonly used in dramas where the rating is greater than 7.0. And we can also create a plot just to give us, to make it easier for us to get this nice, or get a better visualization on how often a word appears. And the way we do this is we are basically calling we need to create keys and values for our bar chart. So the keys is the X value and the values is the Y value. So once you pass it into your plt.bar, you will see that it creates this chart for you. It's very simplistic, but you can see the most common words in order. Almost, yeah, okay. Now we will do the same thing with horror movies. And here you can see we want to look at horror movies where the rating is greater than 6.0. The reason is that there is, as I checked, there was no words. There was very few descriptions or movies that had a rating of 7.0. So I changed it to 6.0. So we do the same thing. We get the we get the data frame where the genre is horror and where the average vote is 6.0. And next we will do the same thing as before. We will first create a list of all the lemmatized words in our data frame. Then we will connect the lists of lists to one. And then we basically apply the counter function on our list, on our long list, to count how often a word appears. And we will transform this, BOV stands for bag of words. So if I run this, let me show you what the bow looks like. This is what it looks like. So you can see that it basically counts how often a word appears. But what we want to do is we want to take a look at the most common words. So that's why we pass it 10, which means the top 10 words in our dictionary here. And we will save this dictionary in our data frame called horror words. And lastly, we will create another chart similar to before with the most common words that came up in horror. So, for example, high school, women, daughter, ghost. Those are some very interesting words. Seems like the highly rated movies include ghosts and high schools. So you can get the idea. Okay. Which genres tend to have the longest descriptions? Does duration of movies impact the length of the description? Let's take a look. Just to remind you how data frame looks like. The script duration is the duration of the movie. And we also have the number of words, so the length of the description. Okay, so we will use a simple group by statement to find the average number of words in descriptions of each genre. So, okay, so we will use group by, we want to group it by genre and get the average, then round the average to 0 decimals and sort the values in descending order. So you have to pass ascending is equal to false and look at the first 5 entries. So we can see that here the most words or the longest movie descriptions are 47 words and include family, romance, sci-fi as the genre, family, war, action, biography, comedy, and so on. And next we'll take a look at the tail. I want to see the lowest. Okay, so mystery and romance has only 2 words on average. That looks a little bit shady. So let me take a look at that. You can see that some descriptions don't make sense. So that is why you get 2 here. Yeah. Okay. And to answer our question, are these movies with the longer descriptions longer in duration? Let's take a look. So we need to group by genre again, get the average duration of each movie, and see what we get here. On average, the longest movies are action, fantasy, horror. So we can see that horror, actually, let me put head. Not necessarily, it doesn't mean that because the movie description is longer, that the duration of the movie is longer. So you can see here, action, fantasy, and horror have the longest movies. They are coming here, it looks like they have longer descriptions. But for example, family, which appears here in number 1, is actually not even showing up here. So it seems like family movies are usually shorter or romance, but have a high or long description of the movie. Okay, so that was the analysis on movie descriptions, natural language processing. I will have another video coming up where we will go more into machine learning with textual data. But I hope you enjoyed this video. and leave some feedback behind so I can improve future videos. And yeah, thank you so much for watching.